In Chapter 9, we're going to continue talking about solving quadratics and their properties. In Section 9.1, we're going to talk specifically about the square root property and completing the square. Now, in previous lessons, what we would do is we would see a quadratic equation like you see here, and we would try to factor it. So x minus 3, x minus 2 equals 0. And then we would solve x equals 3, x equals 2. But if you take a look at the second quadratic equation that we have, x squared minus 8x plus 6, if I try to think of factors of 6, I get 1, 6, 2, and 3, neither of which give me negative 8, which tells us that that equation is unfactorable. So we're going to talk about how you solve that one more specifically later. But the key to this is to know that not everything factors. The first concept of this chapter that we're going to talk about is the square root property. And what it says is if x squared equals k, then x equals the square root of k, or negative square root of k. And this should make sense because let's say, for example, I have x squared equals 9. X equals plus or minus the square root of 9, which is plus or minus 3, because I am squaring a number, meaning that I can take a negative and square it and it becomes positive, or I could take a positive and square it and it becomes positive. Thus, it results in two answers. So, if we take a look at example number 1, where you have a variable squared, like we have the x squared, you can simply isolate the x squared and take the square root of it. So what we'll do is we'll add 54 divide by 3, and get 18. Now what I'll do is since the quantity is squared, I can take the square root, and what you have to remember is that it becomes plus or minus square root of 18, and then you're going to simplify it. Plus or minus, this becomes 9 times 2, so it's 3 square root 2. If I look at the second example, again, that quantity is squared, but this time it's an entire quantity in a parenthesis. So I'll do the square rooting first. So you end up getting 3x plus 1 equals plus minus square root of 2. From there, I'm going to isolate the x, get 3x equals negative 1 plus or minus square root of 2. We can't add or subtract those because they're not the same radical. And then finally, we'll divide by 3. Now I can separate it as negative 1/3 plus or minus square root of 2 over 3. What we're going to finish with today is completing the square process. Now if I look down at the bottom at example number 3 of x squared minus 8x plus 6. So the idea we talked about with the square root property of just taking the square root doesn't really work because we have that 8x there. So we can't do that to both terms. So we have to do something called the completing the square process. Now, I usually break it down into 6 steps. You can kind of switch these around sometimes, but this will give you a general idea of the process that you're doing. I like to make sure it's in standard form, ax squared plus bx plus c. Then I try to divide every term by a. You want that coefficient to be 1. I'm going to bring c over to the other side. And when I do that, I'm going to leave an empty space or a box in its place when I bring it over. Then I'm going to add b over 2 squared to both sides. By doing this, it makes the left side factorable, a PST to be more exact. So you'll factor it, and then you're going to use the square root property to go ahead and finish the problem. So I kind of go through the checklist. Is it in standard form? Do I need to divide by a? both of those, it already worked out. The leading coefficient's 1, it's already in standard form. So now what I'm going to do is I'm going to bring C, which is 6, over to the other side. And what you'll notice is I'm going to leave a spot there. It'll kind of make sense into why in just a second. The next step says I need to add B over 2 squared to both sides. Well, B is negative 8. So negative 8 divided by 2 squared is negative 4 squared, which is 16. So I'm going to take that 16 and I add it to both sides to keep it balanced. And you see how that fits in that spot nicely. What that does is this makes this a PST, and so we're going to factor it as such. And now I'm back to that square root property. I'm going to take the square root of both sides. I'm going to x minus 4 equals plus or minus square root of 10. And then I'm going to add 4 to both sides. I can't simplify square root of 10 or combine those, so those are my two solutions. One is 4 plus square root of 10. One is 4 minus square root of 10. In your homework, you're going to get a couple that are a little bit messier just because they're going to have some fractions that maybe don't divide quite as neatly. But that's okay. You still go through the process the exact same way. And make sure it's in standard form. I want to divide by A, and I want to bring C over to the other side. So I'll do that now. Now I'm going to add, in this red, B over 2 squared. B happens to be 3, and you'll notice that doesn't simplify. That's fine, I'll still put 9/4. So I put 9/4 to both sides. And again, even though it doesn't look like it, this left side is factorable. It's going to become x plus 3/2. Square root of 9/4 is 3/2, or I can take 3 divided by 2. It's the same thing. So then I'm going to equal it. I'm going to need a common denominator. 4 over 4 plus 9 over 4 equals 13 over 4. And finally, we're going to square root both sides. Again, I'm going to put plus or minus out in front. X plus 3/2 equals plus minus square root of 13 over 2. I'm simplifying the radical. So x equals negative 3/2 plus minus square root of 13 over 2. So now I'm going to look at number 5. It's in standard form, but I'm going to notice not everything, or A is not have a coefficient of 1. So I'm going to divide by 3. And that makes that coefficient 1. And now I can start the process from here. I bring C over to the other side. I'm going to add B over 2 squared, which is 2 over 2. Happens to be 1. And again, I do it to both sides. I factor the left, and I get 1/3 on the right. From there, we're going to take the square root. We're going to get x plus 1 equals plus minus square root of 1 over square root of 3. I need to rationalize this though too. So I'm going to get x, I'm going to subtract 1 plus or minus square root of 3 over 3. Go ahead and pause the video for this last one and see if you come up with the same answer as I do. All right, you will notice in this case that I didn't have to bring C over to the other side because it's already there. Also, you'll notice that when we get to the answer, it was imaginary, so I do pull out that I.